to Sabuki's Tutors, we are going to be building the infrastructure we stopped last week. We are going to be building it today. Okay, so we are going to be discussing physics. Then the topic is pressure. We are going to be discussing physics, pressure in fluid. So when you go to any of our channel, whether YouTube or Facebook or TikTok, you can just type Sabuki at pressure in fluid. You see our update. Like any topic, we are going to be taking it topic by topic. Okay, so if you want to learn pressure in fluid, you just type Sabuki and type the topic you want. You see all of them. So all our programs that we are going to be posting it online, so that you can be able to help yourself. Remember what we said, that the question is going to comprise from WAEC, from JAM, from NEPO, and GCE. So we want to know the reason why students fail. Of course, one of the reasons why students fail is because they don't read and because they don't have the requisite exposure as touching the courses they are meant to write in the exam. So if by the time we finish solving like 30 questions under this topic, I don't see a reason why a student that have been able to enter or dive into the system will fail. Okay, now let's continue. Then I have a question here. Okay, number one. This one is not question 4. This one is where? 2008. They said a rectangular block look out. Look at what we have. This is WAEC 2008. Okay, they said a rectangular block of dimensions 2.0 meter by 1.0 meter by 0.5 meter weighs 200 newton. They say we should calculate the maximum pressure exerted by the block on the horizontal floor. Okay, remember in our last class we said something about that maximum pressure. We said something that maximum pressure will exert a force on what? On small area, okay, or minimum area, since I'm using maximum or minimum area. Now, what does it mean? Now, from definition, we say that pressure, if you can recall, so that pressure is the average force per unit area. Pressure is the average force per unit area. Now, from this statement, we are able to establish the fact that pressure varies as force. Look at that, pressure varies as force. We are able to establish the fact that pressure varies as force. Then pressure varies as 1/8. Now what does it mean? Pressure is directly proportional to the force or the weight of the body. Then pressure is indirectly proportional to the area. Now in this case, if the pressure is increasing, of course the force is meant to increase. So increase in pressure will lead to the corresponding increase of force. If the pressure is also decreasing, force is going to decrease. But when you come to this man, when you come to pressure and area, something strange will happen now. Now, because pressure is indirectly proportional to area, it means that as pressure is increasing, this one will decrease. So if pressure is increasing, if pressure is increasing, our area will decrease. Okay? Then if the pressure decides to decrease, that means the area should what? The area should increase. Okay? Now you can see they didn't just tell us to find the area, they say we should find the maximum pressure. So if we are going to find our maximum pressure, we are going to consider the area. The area must be minimum. The area of the rectangular block must be minimum. Okay? Okay. Now, having said that, I will now say that dimension. Of course, they give us the dimension. Now, what is the dimension there? They say it is 2.0 meter by 1.0 meter by 0.5 meter. Okay. Then weight. What is my weight? Okay, sorry. Let me before I go down to the weight. Now, these are the dimensions that was given. 2.0 by 1.0 by 0.5. Now we are going to check. Of course, you know that area of a rectangle is length. So we know that area of a rectangle is length times breadth. Look at that. Area of a rectangle is length times what? Times breadth. Okay. So if it's length times breadth, now these are dimensions that was given. Now we are going to choose. We are going to check the one that has a minimum area. Remember, because they say we should find the maximum pressure, the area we are going to use to solve this question must be minimum. Okay? Of course, I've already explained it that if your pressure is maximum here, your area should be minimum. That means if the pressure is increasing, your area should decrease, because pressure is indirectly proportional, inversely proportional, or indirectly proportional to the area, to the cross-sectional area of the object. Okay. Now, if I multiply these two, if I take this one to the length and this one to the breadth, so 2 times 1 is going to give me how many? 2. Okay? Then if I decide to use this one as length and this one as breadth, so 2 times this one also is going to give me 1. Okay? Then let me now do, since I've done this and this, I've done this and this, then I'll now do these two persons now. So 1.0 times 0.5 will give me 0.5. Now, so among 3 of them, we have 2. We have 1, we have 0.5. So among 3 of them now, we are going to choose the one end of the area that is minimum. Of course, you notice that 0.5 is minimum here. Okay? 0.5 is minimum. Now, if 0.5 is minimum, that means from this dimensioning now, I will take my length. My length is going to be 1.0 meter, while my breadth or my width will now be 0.5 meter. Okay? So I will now say area of rectangle is length times breadth, which is 1.0 times 0.5, that area is 0.5 meter squared. So look at the area we are using. The area will now be 0.5 meter squared. Okay, having said that, then I will clean the board, so that I will clean this part, then we'll see what happens. Okay, now I've gotten the force. Okay, sorry, they give us weight. They give us the weight. Weight is 200 Newton. So we are looking for P maximum. We are looking for maximum pressure, was not given. Maximum pressure, P maximum is what you are looking for. So if you are looking for P maximum, and I will say using. So which formula are we using? Of course, we have many formulas as touching this topic. We are going to check now that we have known. Of course, I know I'm looking for pressure. Weight is given and I've gotten area. So I will say using pressure is equals to, look at that, pressure is equals to weight all over area. That is P is equals to W over A. So this is what you can use. Okay? Now, if I don't want to use for weight, assuming force is given, it's going to be F over A. Because you know that weight and force are the same thing because they are measured in Newton. Some of them are also vector quantities. Now pressure, the P maximum here is going to, what is our weight? Our weight here is 200 Newton all over. Our area on the board is 0.5. Look at that, 0.5. So finally, my P maximum, our maximum pressure, this device to give us 400 watts, 400 Newton per watt per meter square. So this becomes our final answer. Thank you. Okay. Now, maybe I'd like to start the graph and see very well. So this is JAM 1986. This is JAM 1986. Okay, so this is question number 5, Jan 1986. They said a rectangular tank contains water to a depth of 2 meters. So this depth is set as height. Remember in our last class I said that depth is set as height. Of course, pressure is dependent on two things. We have like pressure in liquid is dependent on two things, on two parameters, which are density and what, and depth or height. Okay, so this depth means height of 2 meters. They said if the base is 2 meters by 3 meters, they say we should calculate the force. Calculate the force on the base. Calculate the force on the base. Then they gave us the density of water to be 10 power 3 kilogram per meter cube, and G is equal to 10 meters per second square. Okay. Now, the first thing we are going to do, of course, the first thing we are going to do is to bring out your parameters. So we are going to bring out the parameters to enable you know the formula you are going to use. Okay? Of course, you know we have in the course of the proof. If you get our first episode, you are going to see we are able to establish some facts, some coordinates. So we have some formulas over there. Okay? So when you bring out the parameters, then you now know which one to use. Okay. Then let me continue. Now the depth, of course, I'm seeing the depth here, which is 2 meters. So the depth is equal to height, height is equal to 2 meters. Again, then the base. Look at the base that was given. So let's give the base 4 meter by 3 meters. Okay, I will talk on this base. Then we have force. F is question mark. We are looking for that. Then G is 10 meters. Okay. Let me put G to be 10 meters per second square here. Then this other one, density of water. Density of water, rho W is 10.5 kilogram meter per 3. Okay, density of water is that. Okay, now we are looking for force. Okay, if you are looking for force, then I will solve. Now I will not say record. Record that. What are you recording? We call that density is equals to mass all over volume. Look at that, mass all over what? All over volume. Density is mass over volume. Now, I don't know mass. Of course, if I want to find force, put a formula for force here. You know force is mg. I know my g, so I need to get my m. Okay, I need to get my m. So, and that's why I'm using this formula. Okay, I'm using this formula. Okay, now, then density, I know the density. The density is this man. I don't know the volume, but I can get the volume from the parameter. Now, this is base. This base here is talking about the area. So this base is talking about the area, the base area of this rectangular tank. That is the base area is this one. Okay. So that means from here I will say but base area is equals to what is the base area? Because base area is length times breadth. So what is length here? Length is 4 here times the breadth is 3, which is equal to 12 meters square. So the base area is 12 meters square. Then of course I know that volume is equal to base area times height or depth. Okay, so what is base area? The base area here is 12 times my height. What is my height? My height is 2, which is equal to 24 m cubed. Of course, 24 m cubed. So we have gotten our volume. Our volume is 24 m cubed. Now, if I've gotten that, then I will put this here. I will now say this implies, or I will say but density is equal to mass all over volume. Look at that. Density is equal to mass all over volume. So anywhere I see density, what am I going to put? I will come here and put 10 power 5. Anywhere I see mass, it is mass we are looking for. Then anywhere I see volume, I will now put this volume that we just got now. Okay? So we have, okay, let me cross multiply it first. This one is what? This one is 10 power 5 is equal to m all over v. What is my v? V is 24. Okay, please. Sorry, there was a mistake here. The density was 10 power 3, not 10 power 5. Okay, from the question. Look at it here. Okay, so if I make over 1, I will cross multiply. M times 1 is m. Then this times this is 24 times 10 power what? Now 3 all in kg. So we are working the kg now. I will now say using. What are we using? That's F is equal to mg. Look at that. We are using F is equal to mg. Now what is our m? We have gotten m to be 24 times 10 power 3. Then times what is our g? Our g is 10. From the question it was given already. Is 10. So F is becomes 24 times 10 power 4. Okay? Newton or F. This is standard form. I can make it to be in whole number by making 2 4, then I'll add 4 zeros, 1, 2, 3, and then 4. So this becomes the answer. So this is the answer for the 4. This one is in standard form. Okay, I play. Is that on? Okay, so the force is going to be 2.5, sorry, 2.4. If I move 1 here, if I move 1 there, then 2.4 times 10 power. I'll add 1 here, which is 5, all in Newton, or F can just be 2, 4, 1, 2, 3, and 4 Newton. So this is answer in standard form. Then this look at the answer in our number. Thank you. Report.
I see Jesus. I'll run. Jesus, I'll keep running. I'll keep looking up to you until this flesh will die completely. Savior, I'll come running. I'll keep looking up to you. Run, run, to only you I'll run. Yes, to the cross I'll run. Jesus, to you I'll run. Hey, I'll run. To only you I'll run. Yes, to the cross I'll run. Jesus, to you I'll run.
Question. This is question number 6. We'll find this one from WAEC 2002. WAEC 2002. Okay, let's read the question together. They said a 5 meter by 4 meter by 3 meter. This times means by. Okay, it's just a dimensioning. So a 5 meter by, this is by, times is by. So don't go and multiply your own. You understand? It is by. This means 5 meter by 4 meter by 3 meter vessel of negligible weight is filled with a liquid of density 2,500 kilogram per meter cube. Then they said if the vessel is placed on a flat surface, if the vessel is placed on a flat surface, they say what is the maximum pressure it can exert. Now you can see they gave us they didn't just tell us to find the pressure. They told us to find the maximum. If you find the maximum pressure. So if we must find the maximum pressure, of course, you know that the area is going to exert must be minimum, okay? Maximum area because, why? Because pressure is indirectly proportional to the area. So the moment the pressure is maximum, that means the area should be minimum. Then if the pressure is minimum, the area should be maximum, okay? Now, having said that, now look at our dimension. I'll bring the dimension is 5 meter by 4 meter by 3 meter. Okay? Then let's do the analysis here. 5. Okay. So let's do now. Remember, our goal is to find the minimum area. We need to find the minimum area since maximum pressure was given. Okay. Now this 5 times 4 is 20. Then 5 times 3 is 15. Then 4 times 3 is how many? And is 12. So among these 20, 15, and 12, the least area among them is what now? Is 12. So if the least among them is 12, that means I will take this one to be length, to be my length, because 4 is greater than 3. So I will take the 4 to be my length, then 3 should be my what? And breadth, or of course, it can be width. Okay, so from here, I will quickly get my area immediately. I will say that area is equal to length. Okay, sorry. Let me from here, from the dimension, I know that I will know that my length here is 4 meter, then my width or my breadth is equal to 3 meter. Okay? Is equal to 3 meter. Then I will now say, but area is equal to length times breadth, so which is equal to my length here is 4 times 3, which is equal to 12 meters squared. So our area is 12 meters squared. That is the area we are going to use as touching this question. Okay, then I will continue again. Then I will now say, I will bring another parameter. The next that was given was density. So look at density. Look at density is 2,500 kilogram per m cube. Then if the vessel on this, okay, we are looking for P maximum is based on mass. Now, this is what we have. Now, if this is what I have, of course, now G was not given, but G should be there. So I can still put my G. G should be there. G should be 10 meters per second squared. Please ensure you put your G. Okay. Now, if you have gotten this, then I can start. Now, when you check, if I want to find, I know that pressure is force all over what now? All over area, right? I know my area, but I don't know my force. Okay? Then, if I say, of course, force is mg, look at that. I know my g, I don't know my m. But I know that m is equal to rho V. So that means P is equal to rho Vg all over area. Okay? That is the formula I'm going to use now. I want to find this man. I know density is there. I know I can get my volume. If I want to get my volume, I can multiply everything there. I can multiply 3 of them to get my volume. Okay, so let me get volume yet. So volume is going to be 5 times 4 times 3, which will give me how many? Which will give me 60 m cubed. Okay, volume here will be 5 times 4 times 3. Volume will be 5 times 4 times 3 to give me 60 m cubed. That is the volume. Okay, then I will say using. Now look at the formula we are using. So using pressure is equal to rho Vg all over A. Okay, what is my density? Our density is 2,500 times our volume is 60, then our G is 10. All over our area there is how many now? Is 12. Okay, now when you punch, what are we having? If you punch, what are we having is pause. Okay, so when you divide, we have your, you now say therefore, your P maximum is 1.25 times 10 power what? 5 Newton per watt per meter square. Okay, so that is the answer. Or if I don't want to go that way, I can simply say, just using, look at this formula, I can just say using pressure is equal to density G and H. Okay, now H was not given, but for this question, since from the dimension, look at dimension here, 5 by 4 by 3. If we have taken this man, if we have taken this 4 and 3 to be our area, look at that, to be our base area, that means this 5 should be our what now? Should be our height. Is it true? I mean, from the dimension, since we have taken 4 times 3 to be our area, that means this remaining 5 now should be our height. So invariably, I would say that my height from the dimensioning, I would say that height from my head is 5 watt per meter. Okay? Alright, let's go. Pressure is now density. What is density? Density is 2500, I mean, times G is 10, then this one is 5. Okay, multiply it again for me. So I will still have 1.25, is it true? Times 10 per watt now, times 10 power 5 Newton per watt per meter square. So you can see any of them. Anyone you choose is okay. Okay, so this one is all about reasoning. You have to reason. Remember, in the exam hall, all of us are not going to reason the same way in the exam hall. And some might decide to follow this approach, while some might decide to work it using this method. Okay, I will copy. Let me copy.
At the end of the day, they come and tell me that God was a fluke, He wasn't existing. I will be glad I served that the Buddha. Why are we serving God? It's because of what we want to get. If He does not do it, will you still stay? Are we not all using God? Let's check it. Are we not using God? Why are you serving Him? It's not because of what you get. If He does not do it, you will say, God, I'm tired, leave me alone. But God is calling us unto the Buddha. There is more to let the money. My life is yours, is yours, is yours. Whatever is yours, it is yours.
under my solution. And this is question number 7. This is question number 7 on the board. We have point from JAM 1998. JAM 1998. Okay, now let's read. Okay, now this is question number 7, JAM 1998. So let's read the question together. The question says the atmospheric pressure due to water is 1.3 times 10 power 6 Newton per meter square. They said, what is the total pressure? What is the total pressure at the bottom of an ocean 10 meter deep? What is the total pressure? Okay, so what is the total pressure at the bottom of an ocean 10 meter deep? So they give us some parameters in the bracket. They give us density of water to be 1,000 kilogram per meter cube. They give us G, acceleration due to gravity, to the 10 meter per second square. Okay, so we bring out our parameters. Remember how we solve? You bring your parameters, then you know the formula to activate in solving it. Okay, now let's build the infrastructure together. Now, the atmospheric pressure, of course, you know what our atmospheric pressure is, a pressure that is exerted by air in an object in contact. Okay, so P ATM is my atmospheric pressure, which is 1.3 times 10 power 6 Newton per meter square. Atmospheric pressure is 1.3 times 10 power 6 Newton per meter square. That is your atmospheric pressure. Okay, then we are looking for the, so what is the total pressure? So look at the, say we should find total pressure. So P22 is question mark. We are looking for the total pressure, PT, P of T. P of T is the total pressure. We are looking for it. Then they give us at the bottom of an ocean 10 meter deep. So the ocean deep, look at this here. Ocean deep is talking about the height. It's talking about the height. So H is equal to 10 meter. Then finally, our G here is 10 meter per second square. Then density of water rho is equal to 1,000 kilogram per m cube. So this is parameters we need, okay? And having gotten the parameters, we can start solving now. I will say use it. So what are we using? That pressure is equal to P22 is equal to P ATM plus rho GH. So look at the formula we are using. Because in this question, I know total pressure is what you are looking for. They give us atmospheric pressure. Then I know this one, density is here, G is here, and our height is here. So this is the perfect formula to use. You can see this one, I'm not going to use force over area, because area was not given. Neither am I going to use only this one, because atmospheric pressure was given. So you are not going to neglect it. There's a formula connecting it to that of total pressure. Okay, so continue. Now, the atmospheric pressure, if I remove atmospheric pressure here, what am I putting? 1.3 times 10 power 6, then plus, I'll open bracket so that I'll be able to multiply these parameters here. Density here is 1,000, so I will come here and write 1,000 times our G is 10, I will put 10, then times my height, our ocean deep, which is the height, is also 10, okay? So which is 1.3 times 10 power 6, then this one is 100,000. Look at that, 100,000. Okay, so when you multiply, we have it to be 1.4. We have it to be 1. Please multiply for me. Let's multiply. 1.4 times 10 power 6. Abi?
Yes.
Times 10 power 6 Newton per what? Per m squared. So the answer is 1.4 times 10 power 4 times 10 power 6 Newton per meter what now? Meter squared. Okay, so that becomes your answer on this one. Okay, so is there any question here? Okay, in the absence of no question, copy. Copy.
Romans chapter 8, verse 11. The Bible says, if the same Spirit that raised Jesus Christ from the dead lives inside if the devil is not. The church will rise again. But on the wings of purity shall we rise. Can you pray this? Capito Saint-Tempola. Catila Toberata. Fina no Selene.
But I said I think this word is open on this side now.
Shit.
Okay, let's go. This is question number 8. State in pressure is filled. WAEC 1998. WAEC 1998. Okay, let's read. They said a pilot records the atmospheric pressure outside his plane at 63 cm of mercury. This Hg means mercury. That is a symbol for mercury. Hc mercury. Why a ground observer, that is the person on the ground, records a reading of 75 cm of mercury with his barometer. Now, barometer is an instrument for measuring the mercury. But assuming that the density of air is constant, they say we should calculate the height of the plane above the ground. Calculate the height of the plane above the what now? Above the ground. Okay. Now we are going to, they tell us to take the relative densities of air. So air and mercury, so the what? This and this. So that means air. Density of air is this one. While density of mercury is what now? Is this other one. Okay. So I have under my solution, I will have it to be this. Now, when you look at this case, we have mercury and air. So we are going to say pressure change. I'll start by saying that pressure change in air is equal to pressure change in mercury. Now this mercury can be liquid. There are some things that will tell you it is liquid. Okay? So pressure change in air is equal to pressure change in what now? In mercury or liquid. Okay. Then of course you know that the general formula we are going to use is this man. The formula we are going to use is density is equal to, sorry, pressure is equal to density times association due to gravity times height. Okay. Now having said that, now because we have it in air and in liquid, so that means I'm going to have rho GH all in air is equal to rho GH all in mercury. Let me use mercury, or I can use what's it called? I can use air. Okay. Now G is constant in all of them, so I can just cancel, and I will have it to be rho of air, H of air is equal to rho of mercury, then what again? H of mercury. So this M is mercury. Okay, so bear with us. Now let me analyze the statement. Now look at the first pilot. Look at the pilot here. The pilot is on air, and he was able to measure from his measurement. He was able to use the barometer to measure the atmospheric pressure to be 63 centimeters. Idea 63. Then another man was on the ground. Look at this now. Another man was on the ground observer. So this one is the pilot. Then this one is the ground observer. Look at the ground observer. He measured 75 centimeters. Now the pressure change here is my h, my small h. Okay, and that should be that. Okay. Now the difference, there should be a difference between two of them. Okay. Now when you look at the question, what are we actually looking for? They say we should calculate the height of the plane, above the ground, the height of the plane above the ground. Okay, if that is that, then I will have that what is my density? My rho of A is 0.00136 kilogram m per cube, meter just power minus 3. Then rho of m is what? Is 13.6 kilogram m minus 3. Okay, then I'm using this one. So using rho A H A is equal to rho m and H what now? H m. Okay, so if that is that, then I will have that HA is equal to rho m HM all over rho A. Okay, so rho m is what? What is our rho m? Is 13.6. Then times. Now this HM is the height of the liquid. That means it's going to be the difference between this man. So we have 75 minus 63. Then all over this man is 0.00136. Okay. So please, they say the height of the plane above the ground is the height of the air. The height of the air is what we are looking for. Okay, we have 13.6 times. When you subtract, we have, I think it's 12 we are having. Then all over 0.00136. Okay, when you divide finally, we have it to be in 1000. Please point for me. Say 12,000 centimeters or 1,200 centimeters. Please point and check. 1,000 because this can cancel. 1, 2, 3, 4. I cancel this one.
1.2
Okay, 12,000 of it. Okay, all in centimeters or 1.2 times 10.5 centimeters. So that becomes our answer. Okay. Now, if you have any question, okay, there is no question, just copy the solution. Thank you. Okay, so this is question number 9. Question YA 2010. Question number 9 YA 2010. Okay, let's do the question together. They say two vertical capillary tubes of the same diameter are lowered into beakers situated at the same level, containing liquids A and B of densities 9.2 times 10 power 2 kilogram liter less power minus 3 and 1.30 times 10 power 3 kilogram per m cube, respectively, full stop. they said a suction pump is used to withdraw air from the top of the liquid columns in the tube by means of a Z-piece arrangement until the liquid in air rises to a height of 26.0 centimeter. They say we should calculate the height of the liquid in tube B. Okay, so under my solution, then what are we solving? Now, the first one they gave us densities here. Two densities are here. So because they say respectively, then it's the density of A. Density in A, density into A is equals to 9.2 times 10 power 2 kilogram per m cube. Density into B is 1.30 times 10 power 3 kilogram per meter cube. Okay, then we have the height of liquid A. So we have height of tube A, which the height of A was given to be 36.0 centimeter. Then the height of tube B, the height of tube B, height of B is what we are looking for. Okay, so I'm using now, you know what I'm using. Okay, I will say from. What are we froming? That pressure is rho G of H. Now, because we have two tubes in both, we are going to have rho GH of tube A will be equal to rho GH of tube B. Now, the G is always constant, so I will cancel. So we have rho of A, H of A is equal to rho of B and H of B. So this is the formula we are going to use. I can just state it from here. I can just state it from here. No need of proving all of that because I've already stated it before now. Okay. Now if I make H be the subject, I'm having rho A, HA all over rho B. Okay, which is equal to, let's substitute. Anywhere I have rho A, that is density of A, I am putting 9.2 times 10 power 2 times the H of A is 36.0. Then all over density of B is 1.30 times 10 power 3. Okay? So H of B, because when you multiply everything, what are we having? When you multiply everything, we have 18.4 centimeter. 18.4 centimeter. That becomes our answer. 18. When you multiply, you get 18.4 centimeter. Now you can see I didn't convert the centimeter to be in meter. Remember, we are able to convert all our centimeter to go to meter. Because the person was given the option was also there's no need of converting in this one. Or if you still want to convert, I can still convert it from here. But if I convert it, I will divide it by 1,000, which will give you 0.184 meters. If I convert this one now to be a meter, I will divide this one by 1,000, sorry, by 100 to get 0.184 meters. Okay, then if you have any question on this one will be solved. Okay, in the absence of no question, I copy. I will call it a copy. Copy. Okay, copy that. Are we good? Okay, on to my solution. Now this is question number 10. JAMB 2004. Question number 10. Question number 10. Okay, let's read. Then it said a 40 barometer reads 72.6 centimeter mercury when the atmospheric pressure is 75.0 centimeter mercury. They say we should calculate the atmospheric pressure when this barometer reaches 72.0 centimeter mercury. Okay, now I will start. Now this is the normal pressure, so P is equal to 72.6 centimeter mercury. Then the PATM is equal to, okay, let me call this one P1 and PATM1 is equal to 75.0 centimeter mercury. They say we should calculate the atmospheric pressure, so PATM2 is question mark when our normal pressure is 72.0 centimeter mercury. So look at that. So we have pressure. They say calculate the atmospheric pressure. We are looking for that. The second atmospheric pressure when the normal pressure is 72.0 centimeter. Okay? So I'll start solving. So using, now look at the formula I'm going to use in this man. I will have that P1 all over PAC1 is equal to P2 all over PACM2. So this is the formula we are going to use. Okay? We are going to use this formula. Okay? Now, the first pressure, the P1 is 72.6 all over PAC1 is this one, which is 75.0 is equal to P2 is 72 all over PACM2 is what we are looking for. PACM2 is what we are looking for. Okay? So at this junction, I will cross multiply. You cross multiply. So when you cross multiply, this times this will give us 72.6 PACM is equal to this times this will give us 75.0 times 72. Please point for me. Okay, if I make PACM the subject, I will have PACM2 is equal to 75.0 times 72 all over. This one will now come under here, 72.6. As when you cross again, when you cross multiply, this one will still go back again. Okay? So when you multiply this times this, divide by this, I will have 74.4. I will have 74.38 centimeter mercury. So PACM2 becomes 74.38. So approximately, because this is an OBJ question, okay? In the option, they didn't give this one, rather they gave us 74.4, okay, centimeter mercury. So in the option, look at what they gave us. So because in the option, please, anytime if you are solving an OBJ question, of course this will jam. If you are solving an OBJ question, when you get your answer, when you get the answer, go to the option and check. Go to the option and check how it works, how they put theirs. Idea? If they let their own this way, then you leave your own that way. But if they approximate, please ensure you approximate. Are you with me? Because when you get this now, if you go to the option now, you are not able to see this thing. You can see what we had in the option was 74.4, which of course when you approximate this one, you approximate the one decimal. From here, look at decimal point. If I move 1, I'll stop here. This 8 is above 5. So 5 and above, you just take 1 and put here, add 1 here, becomes 74.4. So if I add 1 here, it becomes changes from 3 to 4. So 74.1 now, 4. Okay. Is there any questions? Okay, in the absence of no question, I copy. Let's solve another number. So this is number 10. The next number is number 11. We are going to solve number 11 now. Thank you. What? I think so. Okay. Let's go. Now, this is question number 11, GCE 2004. They said an open U-shaped mercury manometer is used to measure the pressure of a gas. First of all, they said the mercury in the open tube is 0.60 m higher than that in the ring, which is in contact with the gas. So we should draw a diagram of the manometer to illustrate the given information. So we are going to use a sketch to illustrate this information. II, they say we should calculate the pressure of the gas. They give us density of mercury is 1.36 times 10 power 4 kilogram per meter cube. G is 10 meter per second square. Then atmospheric pressure was given. Okay. Now for I, look at my eye. I want to sketch. Now I will sketch it. I look at my sketch here. So that I've not done this sketch before. I think it's good we learn it now. Okay, now this place is okay, here is my P. This one is my atmospheric pressure. Then this place is just my P, my normal pressure. Okay. Then if I'm taking that, of course, I'm going to take from here. Okay. So this is what we have. So this is the sketch of what we need now. This one is gas supply. This place is gas supply. We're going to have a nozzle here. Okay, so this is what we have. So under my II now, what are we finding? Calculate the pressure of the gas. Okay, so we should calculate the pressure of the gas. Okay, now let's go. Now in this case, because they say the pressure, they said the mercury in the open tube is this man, so the height here is 0.6 meter. That is the height. Okay, then the pressure, the total pressure here is H plus H, small h. Now look up here. Now when the pressure of the gas, look at that now, when the pressure of the gas is above the atmospheric pressure, look at the formula we are using. This one is when we use this formula when the pressure gas, when pressure gas is above the atmospheric pressure. The atmospheric pressure, okay? Then when the pressure, like is 2, when gas pressure or when gas pressure is below the atmospheric pressure. I then look at formula we are using P is equals to H minus H like this. Okay? Then the case 3 now. When gas pressure is equal to atmospheric pressure, comma, that means P is equal to H. Now remember in this case now my H is atmospheric pressure. Okay, I think I should just be like this, P HCM. So then this H is temperature, is pressure difference. Okay? This one is total pressure, this one is normal, then this one is pressure difference. H is equals to pressure difference. Okay? H is equals to pressure what? Is equals to pressure difference. Okay, please. After you can copy these cases here. Now I said when the pressure gas is above the atmospheric pressure, I look at the formula we are using. Pressure is equals to the atmospheric pressure plus the pressure plus pressure difference. Then when gas pressure is below the atmospheric pressure, pressure will not be equal to atmospheric pressure minus the what? Minus the pressure difference. But when the gas pressure is equal to the atmospheric pressure, the total pressure is going to be equal to what is called atmospheric pressure. Okay, so that is what we have. Now, having established that point, I will come and solve here. Okay, let me just solve here. See this thing that enter here. So I will have P is equal to P HCM plus H. Okay. Now for that question, what am I having there? We have what are we having? Okay. Let's say, okay, sorry, let me bring the parameters first. So H. Pause. Okay, so we have pressure is equals to P ATM plus this is pressure difference, which is rho GH. Okay, then which is equal to what is my PATM here? The atmospheric pressure is, look at it here, 1.01 times 10 power 5. So if I remove the under atmospheric pressure, look at what I'm putting here, then plus, then density. What is density? Look at density here, 1.36 times 10 power 4. Then times G is 10 times our H. Look at our H here. Our H is 0.60. Okay, which is 1.01 times 10 power 5 plus, okay, this punch 0.816 times 10 power 5. Please check whether this is correct. Then the final answer will now be 1.826 times 10 power 5 Pascal. So the pressure is this. Please check. The pressure is equal to 1.826 times 10 power 5 Pascal. Okay. Is there any question? Okay, if there is no question, please copy so I will see the next question. That 1 Newton per meter square is equal to 1 Pascal, then 10 power 5 Newton per meter square is equal to 1 bar. So please take note of this point. 1 Newton per meter square is equal to 1 Pascal, then 10 power 5 Newton per meter square is equal to 1 bar. Okay? Now above sea level, okay. Then after I will say that if I'm discussing about convert from barometer to this one, I will just use this formula to get it. I want to convert from that to that.
Good.
All of my blessings are divine, oh. When I look around, all I see now your hand, oh. My daddy, oh, when it's hour, you dey make us sweet, oh. This your grace, oh, yeah, you dey speak for me,
oh. Okay. Okay, this is JAM 1995, question number 12. We're number 12 now. JAM 1995, question number 12. Okay, let's read. They said a hydraulic press has a large circular piston of radius 0.8 meter and a circular plunger of radius 0.2 meter. Full stop. They said a force of 500 Newton is exerted by the plunger. So the plunger now find the force exerted on the piston. So we have piston and we have what now? We have plunger. Okay, now under my solution, and I will say let the force on the piston, let the radius, the piston radius is this one. So R1 is going to be radius. Will now be our radius of piston. So which is equal to what? 0.8 watt nanometer. Okay? Then R2 is going to be radius of plunger. radius of plunger, which is 0.2 meter. Okay? Then a force of 500 newton is exerted on the plunger. That means F of 2 is force of plunger, force on plunger is 500 newton. Then F of 1 is equals to question mark. So we are looking for F of 1, which is force on piston. The force exerted on piston is what we are looking for. Okay? So we have R1 is radius of piston, which is 0.8 meter. R2 is radius of plunger, which is 0.2 meter. Then F of 2 is force on plunger, which is 500 newton. Then F1 is force on piston, which is what we are looking for. Okay? Now, because they gave radius, and I know my common sense now, the area of piston, the area we are going to use here should be area of a circle. Area of a circle is what we are going to use, which is equal to pi r squared. Okay? So I will say area of piston is equal to pi r squared, which is equal to pi. Okay? Now r of piston is 0.8 square. Of course, I will square it. If I remove R1, I will put 0.8. If I will square, I will square. So which is 0.64 pi. Is it true? Okay, then we have area of plunger. Area of plunger is pi R2 all in square, which is pi. Okay, if I remove R2, I'm putting 0.2. I will square it. So which is square this man 0.04 all in pi. So I'm cutting that. I will say using, or I will say from. Of course, you know from pressure is force all over area. So I will now say using F1 all over A1 is equal to F2 all over what now? A2. Okay? Alright, let's substitute. So F1, we are looking for F1. Then what is my A1? A1 is what? Where is our A1? Is 0.64 pi. Then is equals to, what is my F of 2? F of 2 is 500 newton, 500. All over then A of 2 is 0.04 pi. Okay? Then I will cross multiply. So when you cross multiply this with this man, which is 0.04 pi of F is equal to this times this one. So 0.64 times 500 is what? 0.64 pi times 500. Then if I make pi will cancel pi. So if I have, then F will now be 0.64. Okay, sorry, 0.64 times this one is 320 all over. Then this 0.04 will come under here, 0.04. So finally I will have 8,000 newton. Okay, 8,000 newton. Okay, so that becomes your answer. Okay, is there any question on this one? If there is no question, I copy, then we'll call it a day. Am I solving any other one? Okay. Okay, so we are going to be stopping here for today's program. So please ensure you join Sabuki Tutors with the phone number. Follow us on Facebook at Sabuki Tutors. So when you go to Facebook, just type Sabuki Tutors, you will see our update here. You go to, if you're listening to YouTube, just type Sabuki. This one should be together. Sam and the Buki should be together. Sabuki, when you go type it, you see up there. If you go to TikTok, just type Sandy and you are going to see. Then if you have, this is our WhatsApp line. In case you want to send us any message on WhatsApp, any question at all, just send it to us on WhatsApp. We'll always be available to address you. We'll always be available to teach you online and any other thing. Okay? So please ensure you like, ensure you comment, share and subscribe. Thank you. See you next time. Thank you. God bless you.